In this example, we want to evaluate the integral of negative 5x cubed over the square root of 4x squared plus 1 dx. So this is going to be another trig substitution integral. And since I've got 4x squared plus 1 in the square root here, I want to use a tangent substitution. And I need to multiply by some coefficient out here so that when I square and then multiply by 4, I want to end up with 1. So that'll be 1 over the square root of 4, which is 2. So my x is going to be 1/2 tangent theta. Then dx will be, the derivative of that will be 1/2 secant squared theta d theta. And if we solve for theta in here, theta is equal to the inverse tangent of 2x. So let's go ahead and substitute into our original integral. We're going to keep the negative 5 up here, and x is 1/2 tangent theta cubed. This is over the square root of 4x, so 1/2 tangent theta squared plus 1, and times dx, and dx is 1/2 secant squared theta d theta. So now let's simplify this expression a little bit. First I'm going to pull out the constants, so I'm going to pull out this negative 5. And then I've got a 1/2 here, and that is cubed. So if I pull that out front, that'll give me a 1/8. And then I've got another 1/2 in front of the secant squared. So I pull that all outside of my integral. And then I'm left with tangent cubed theta on the top. And then I'm just going to bring the secant squared up on top also. And then on the bottom, I've got the square root of, so this 1/2 squared becomes 1/4 and cancels with the 4. So I just have tangent squared theta plus 1 left inside my square root and d theta. Now we're going to use a trig identity here. Tangent squared theta plus 1 is equal to secant squared theta. So if I take the square root of that, then the bottom here is just equal to secant theta. And then I can cancel this with one of the secants on top. So that gets rid of that squared. And I'm left with negative 5. And then multiplying together the 1/8 and the 1/2 is 16ths. Tangent cubed theta secant theta d theta. And I've just rewritten here what my original integral was, and this is where we've gotten so far. And remember that theta is equal to the inverse tangent of 2x. Now we're going to do some more stuff with trig identities. So we have negative 5/16, and I'm going to separate this tangent cubed into tangent squared theta times tangent theta, and I've still got my secant theta d theta here. And then I'm going to use another trig identity. So my tangent squared theta is going to become secant squared theta minus 1. And then I've still got my tangent theta secant theta d theta here. Now to solve this integral, I'm going to use a u substitution. I'm going to let my u be equal to secant theta, and then du will be tangent theta secant theta d theta. And you can see that this is a really nice du because it's exactly the same as what I have here. So this is my u substitution. And let's substitute that in. We get negative 5/16 secant theta is u, so I've got u squared minus 1, and then this whole thing here is just du. So now, in terms of u, this is easy to integrate. I can just use the power rule. So I've still got my negative 5/16 out front. If I integrate u squared, I'm going to get 1/3 u cubed, and then minus the integral of 1 is u, plus my constant of integration c. So now we've got everything in terms of u, and I want to get back to x. So u is equal to secant theta, and theta is equal to the inverse tangent of 2x. So rewriting u in terms of x, this is what I get, and I can just plug that back in here. So negative 5/16. 1/3 u cubed is secant of inverse tangent of 2x all cubed minus u, which is secant of inverse tangent of 2x plus c. And this is what my integral evaluates to. So you can leave it in this form. This is fine. Or if you want to see how we can make this look a little bit better, I'll do that on the next page. So here I've just rewritten my original integral, and then this is the next to last step that we had on the last page. So this is this part here. And reminding you that u is the secant of theta, and theta is tangent inverse of 2x. So then that means the tangent of theta is equal to 2x. So if we draw a triangle here to represent theta, then the tangent of theta is 2x, and tangent is opposite over adjacent. So the opposite side will be 2x, and then adjacent side will just be 1. And to find the length of this side, we're just going to use the Pythagorean theorem, which says a squared plus b squared equals c squared. So this side is going to be given by the square root of 2x squared, which is 4x squared, plus 1 squared is 1. So now let's find out what secant of theta is. So u is equal to secant of theta, and secant is the hypotenuse over the adjacent side. So that's just equal to this square root here over 1. So square root of 4x squared plus 1. So now we have u written as this square root instead of having it written as the secant of the inverse tangent. And we can substitute that in for our u. So this is my original integral again. And this is now equal to negative 5/16 times 1/3 u cubed. So u is the square root of 4x squared plus 1. So if I cube that, that's 4x squared plus 1 to the 3/2 minus u, so just minus the square root here of 4x squared plus 1, plus my constant of integration c. So that is another way to write exactly the same thing that we had back here. It just looks a little bit nicer.